So you remember when we were solving linear equations in one variable, there were two special cases you had to be aware of. And in both of those cases, what kind of was an indicator to you that something strange was happening was that the variables went away, right? We can have the same kind of thing come up here with these linear inequalities. All right, so let's walk through our process here. Let's say we were going to solve this inequality here, and we would start by distributing the 4x minus 1, 4x minus 4 minus x is greater than or equal to 3x plus 2. Didn't change the right-hand side. Now I can combine these two like terms. 4x minus x is 3x. I get 3x minus 4 is greater than or equal to 3x plus 2. Now hopefully you see what's about to happen. I'm going to subtract 3x from both sides. All the variables are going to go away. Okay, and kind of looking ahead, to see if you can't kind of figure out what the answer is going to be. If I take this number, whatever it is, and I subtract 4 from it, it gets smaller. Then over here, I'm going to take that same number and add 2 to it. Well, if I take a number and reduce it by 4, and over here I take a number and increase it by 2, is the reduced value going to be greater than the increased value? I don't think so. All right, and you'll see that happen on the next step. So let's say we do our thing. We subtract 3x from both sides. We get minus 4 is greater than or equal to 2. We're going to apply the same reasoning here that we did when we're doing this with linear equations. Negative 4 is absolutely never greater than or equal to 2. This will not happen no matter what value you pick for x. Since there are no values of x that make the inequality true, that's my answer. I would say either no solutions, or there are no solutions if you want to make a complete sentence out of it, or again, we can use that symbol for the empty set here. All right, so let's try another one here. You probably know where this is going to end up if you watch the lecture where we talked about this with equalities, but let's walk through it. I'm going to distribute the 5. Left side stays 5x minus 1, greater than or equal to 5x minus 15. Subtract 5x, minus 1 is greater than or equal to negative 15. Well, yes, it is. Negative 1 is greater than or equal to negative 15 always. Pick any x value, any number you like for x, and that is going to be true. Right, so if this is true for every value of x, then that's my answer. So my answer here would again be either you could say all real numbers, or you remember there's a symbol for it. It looks like this R with an extra line. And again, you can kind of talk your way through this. If we start with 5x and subtract 1 from it, and over here we start with 5x and subtract 15 from it, well, yeah, this number is going to be the smaller of the two because we reduced it by more. Right? So that's kind of the reasoning behind this. So that takes care of linear inequalities. Behave very similarly to what we've already seen with linear equations. So in the next lecture, next couple of lectures, we're going to kind of, again, take another step forward. Now that we know what to do with linear equations and linear inequalities with one variable, well, what if we add a second one?